Hey everyone, this is David Wong, and you're listening to Two and a Half Coin. This is, I believe, the seventh episode of the podcast, and you might actually be watching me if you're watching me on YouTube, because now I'm doing video as well. This is 2024. And I know I've talked about Bitcoin for a very long time. Like I've done like 6 or 5 episodes on Bitcoin, on different subjects of Bitcoin. I really thought that I could get away with less episodes, but there's so much to talk about that I took my time. Now I feel like we should sort of move on. Maybe we'll come back to Bitcoin at some point, but this podcast is really about cryptocurrencies in general. And so I want to spend more time on other stuff. And spoiler alert, today we're going to talk about Ethereum. And there's a lot of things to talk about in Ethereum land. I think this will take more than 5 episodes these times. I believe we might go to like 10 episodes. Like, well, the sky's the limit in terms of what's happening with Ethereum. It's one of the it's probably the second real coin after Bitcoin, and it came out in 2009. But even to this day, it's still one of the strongest coin or cryptocurrency. It's probably number 2 after Bitcoin in terms of market cap, but in terms of excitement and hype and really developer community and projects being built on top of Ethereum and conferences and so on and workshops, and it's really the number 1. And so that's why I want to take my time and really talk about Ethereum as well. If you think of new projects today, most of them are built on top of Ethereum, or their events will gravitate around Ethereum events wherever they are in the world, including the stuff I do, like at ZK Security, the company I founded in the middle of this podcast. We spend a lot of our time in Ethereum conferences just because a lot of the things we do and the clients we have are at these conferences. So anyway, Ethereum is very exciting, but let's get to the meat of it, right? This podcast is a technical podcast. I'm trying to explain things to you. So what is Ethereum? So the main idea of Ethereum was that, if you remember, when we were talking about Bitcoin had this Bitcoin script that was used to lock money. In Bitcoin, you're not really sending money to other people. Actually, what's really happening is that you're creating a UTXO, an unspent transaction output. You're creating a bill, a cash bill, I guess, with an identifier that says you can spend me, whoever, anyone can spend me if you can provide the correct inputs to a Bitcoin script. And so basically what happens is that you're locking Bitcoins, you're locking money somewhere. You're not really sending money to someone, you're locking it, and whoever can unlock it can spend it. Bitcoin script is pretty limited. And so the number of applications that are built on top of Bitcoin is there's not that many, let's be honest. Bitcoin is a pretty slow cryptocurrency to move. Doesn't see a lot of upgrades, or really no upgrades at all. Whereas Ethereum moves quite fast, as we will see in the next podcast episodes, and gets upgraded pretty frequently. And so basically the idea of Ethereum was that let's create a cryptocurrency where people can actually write more interesting programs, can really program money. And they coined the term of smart contracts, which I'm going to use thereafter. And these smart contracts are basically more complex programs that dictates how some amount of money in some, at some address can be spent. And okay, so that's basically how Ethereum came to friction. It was like, we want something more expressive. Bitcoin is not very expressive. Let's create Ethereum. Before I get into the specifics, I want to start with an analogy. And this analogy has served me pretty well. So, bear with me for a few minutes, and I will always come back to that analogy, actually. So it's a good way to start introducing Ethereum. And so that analogy is really, whenever I talk about Ethereum or people talk about Ethereum, what they're talking about is a big computer in the sky. And we're all using the same computer. It's very similar to Bitcoin. You can imagine Bitcoin as being this single computer running a database in the sky, and everybody's using the same database because they're using the same computer. But in Ethereum, you can take that analogy further by saying that you can also install programs on that computer and use programs that other people have installed. And so I'm going to stop saying programs. I should start saying smart contracts, but it's basically the same as a program on your computer. You know, when you install a program on your computer, you can use the program has a state, and throughout your usage of the program, you mutate the states of that program. And you know, if you reboot your computer, the state is always the same. For example, if you take a note-taking app and you create notes and update notes and delete notes, once you take a pause and you come back to your computer, the state is going to be the latest state after you used it the last time. And so here it's the same, except that every application is a multi-user application. So if I take this example of a note-taking app, I would allow anyone, by installing this app on the Ethereum computer, I would allow anyone to use that application. I would allow anyone to create new notes, to look at my notes, to update notes, and so on. And so we're all using this program together, and we are using this program through the interface of the program. And so a smart contract on Ethereum has an interface that dictates how you can use its states. And the states also, I'll give some examples later, but you can think of like arrays or values or dictionaries or it's just a database, or maybe that's what I should say. But imagine that every program or every smart contract on Ethereum has a database behind it, and you can mutate that database by using the methods or the functions of that program, of that smart contract. So anyway, that's the analogy. Hopefully that made sense. And before I can really introduce what these smart contracts are and how you write them, how people can use them, I need to introduce the notion of account-based model. We talked about UTXO, or unspent transaction output, in Bitcoin. These UTXOs are quite annoying because they're sort of like cash. You have to, whenever you want to like change the state of something, you have to move it somewhere else, move it to a new UTXO, and whoever uses that UTXO will consume it and produce another one. So you always try to keep track of like what's the latest ID of a program. And you can't really, Bitcoin is kind of pure in this way. Like whenever you use something, you consume it and you create something new. There's no mutation of something. There's no object that you can modify. And because of that, it's very hard to create shared states. And these interesting applications and smart contracts on Ethereum are all about shared states. I want to, although otherwise, I'm just using that for myself, and there's no point. And so Ethereum created or reverted back to a much simpler model, which is the account-based model. And in the account-based model, you're basically have a very simple dictionary of accounts or addresses to their balances. And if that doesn't make sense to you, you can just imagine a database or a spreadsheet or a table where every row is a user, a column is their address, and another column is their balance. And that's the model of Ethereum. Whenever you want to send money to someone, you just change their balance, you increment it, and you subtract the amount that you're sending from your own balance. There's no UTXO, you're not consuming anything and moving it somewhere else. There's no latest set of all the bills that you can spend. It's just Ethereum, if you think of the state of Ethereum, is just the state of all the accounts and their balances. Thinking about it simply, it's a bit more complicated than that, but in a simple way, it really is like a database of what you would imagine a bank would work. Accounts and balances for these accounts. And so thanks to that, it's much easier to create these smart contracts that everybody can use, because when you create a smart contract, you just create an address. And like a normal address, it has a balance. And so that smart contract can have money, can have Ether. Ether is the unit or the currency in Ethereum. And then you can attach some code to it. So I guess an address is not only associated with a balance, but also some code. We'll see what kind of code, but the smart contract code. And nobody controls that account, but you can refer to that account by referring to the address, kind of like the address of a user, but of that smart contract. And you can mutate the state of that smart contract exactly like you're mutating the balance of an account. And so if that makes sense, that's why it's easier in Ethereum to have these smart contracts that everybody can use. Not that it's impossible to make it work in the UTXO model, but it's much more complicated. Okay, so now I should probably talk about transactions in Ethereum and accounts. Accounts in Ethereum are basically like in Bitcoin. By the way, I've talked about all of these things in previous podcast episodes, so I'm not going to talk about them again. You can listen to the stuff that I've recorded previously if I lost you so far. But yeah, addresses, users have addresses, and these addresses are basically like public keys, and users have private keys. And when they want to do something, they'll basically create a transaction, and that transaction will say, I want to send this much Ether to someone else, and they'll sign it. Because we're not in the UTXO model where, you consume money and then you create it somewhere else. In the account-based model, you have this idea of replays where someone could replay your transaction that says, I want to send 3 Ether to Alice. And so that you cannot replay, there's this replay or no anti-replay mechanism that maybe is worth mentioning, where not only you track balances in accounts, but you also track a number called a nonce for number ones. And whenever you sign a transaction, you sign that number and then you increment that number in the account. So it's not too important to understand, but basically if I sign a transaction to send you money, I will sign the number 1 because that's what's under my account. And then my account will track the number 2. Whoever tries to replay my transaction to the network won't be successful because it will replay a transaction that signed the number 1 when my account has the number 2 under it now. If that doesn't really make sense, don't worry too much. It's really an implementation detail. What is important to think about is what happens when you want to use these smart contracts on the chain. What happens is that you actually sign a transaction like you're signing normal transactions in Ethereum, except that this time you don't say that you want to send some Ether to someone. You say that you want to use a smart contract that was deployed at some address. So instead of saying I want to use the calendar application, you say I want to use the application at address, some address. And then you say I want to use one of these functions. Remember I said that a smart contract has an interface and you can use it through its interface. And so in your transaction, you will say, I want to use the smart contract at this address, and I want to use that function specifically with these inputs. You sign that, you send it to the network, and the network will execute that function for you. And that function will mutate the state of that smart contract, for example, and whoever is running the network will mutate the state of that smart contract in the correct row of the database. Now, so far I've talked about this model of the computer in the sky. Of course, that's not how it works. There's a network. It's very similar to Bitcoin. Actually, it was exactly like Bitcoin when Ethereum came up in 2009, I think. And it's this idea that everybody's running the network, everybody's mining for new blocks. And so when you're executing a smart contract somewhere, it's exactly like you're executing a Bitcoin script function in Bitcoin. And that means that everybody has to execute that function. And when the state of a smart contract change, as someone in a network, you need to execute that function because you need to understand how to change the state of that smart contract. If you don't do that, you just have to trust someone to do it correctly. And in cryptocurrency, we don't like that. We always say things like don't trust but verify, trust but verify. And so the Ethereum network has this kind of wasted computation thing where everybody's always re-executing all of the smart contracts function execution so that they can all agree on what's the new state of the world after executing a bunch of functions in a bunch of smart contracts all over the place. There are ways to avoid that using something called zero knowledge proofs, but I'm not going to talk about that now. But If you want to Google that because you're curious, you can. I will talk about that in a further episode, so you can wait for that as well. But just know that Ethereum is, forces people to recompute things, and it might appear kind of wasteful, but that's basically the most naive way or straightforward way to make sure that everybody's computing the same stuff. Okay, so Ethereum was actually initially introduced in this white paper, often referred to as the yellow paper because it had a yellow background. The real name of that paper is Ethereum Secure Decentralized Generalized Transaction Ledger by Dr. Gavin Wood. And I'll do an episode on that paper specifically at some points, but the introduction of the paper was to introduce what the paper introduced was the EVM, or the Ethereum VM, which was basically this set of instructions that you could use to write programs or these smart contracts. It's quite a low level set of instructions. It's a stack based VM where you're operating on stack elements, you're pushing things to the stack, you're popping things from the stack, and so on. Really like, akin to the instruction set of your CPU or something like that. And so people don't really like to write low level stuff. And so there was also, at some point, I guess, in the history of Ethereum, a higher level language that was introduced called Solidity, Solidity. So Solidity is what most people use today to write smart contracts, and it compiles down to this set of instructions that are the EVM instructions. And if you today want to learn how to use Solidity and to write smart contracts, you would basically follow these tutorials on Solidity, which really looks like sort of like JavaScript. Maybe some people will be mad at me for saying that. And maybe a good recommendation is to use something called Remix, which is just a web IDE that has everything you need to spin off your own local blockchain, write smart contracts using the Solidity language, and deploy them on your fake blockchain and play with them and so on. It's a very simple way to get into Solidity, and I would recommend that to anyone. I've actually used that to even deploy real Solidity programs on the Ethereum blockchain, so it's quite complete and self-contained. Solidity, maybe I can describe it a bit more. It's hard to do it in a podcast because obviously I can't really show you things. But if you were to look at it, it would sort of be something that's creating a class or an object in like JavaScript or similar languages. And the first thing you would define is the state of your smart contract, which usually is a set of dictionaries or associative arrays or hash maps or whatever you're familiar with. But these are always the same stuff. Dictionaries are values to other values. It's a map. And basically, these are key value stores that serve as database for your application. So you have several of them. You might have constants or like whatever. Then you often have a constructor, which is just a function that says, here's the initial state of my smart contract. Usually what you see are in these constructors are something that will set the owner of the smart contract to whoever is deploying the smart contract. This is a very common pattern that allows you to administrate the smart contract after that to do admin tasks. And that's all I say about that. And then after that, you usually see the functions and methods of the smart contract, or the public functions that people can use to use the smart contract. They can call them with inputs, maybe receive an output as a result, and these functions will mutate the smart contract, and you'll have some logic, as in any other language, that will say, is this thing correct? Yes. Okay, I can mutate the state of that smart contract, and so on. And as I said, smart contracts are really addresses on chain. So they sort of are like users. And the interesting thing is that smart contracts can, because they're acting like addresses and accounts, can call other smart contracts. And you have this kind of composition that can happen where smart contracts can call other smart contracts, can call other smart contracts, and so on. And actually that created bugs initially called reentrancy bugs, but I'm not going to talk about that. Creating these contracts is kind of heavy for the world of Ethereum because, as I said, everybody has to re-execute things all the time. So and also deploying something on the chain takes room. The state of the contract takes room. The code of the contract takes room, takes space in the cryptocurrency, in the blockchain. And so you want to limit that. And the way for Ethereum to limit that is to have this notion of gas that, like gas, like you use gas for your car. And if you want to run a program or store a program on chain, you'll have to pay some gas costs. And basically, the way they stated that is that every instruction in the EVM has a fixed cost in terms of gas. The same way your car has a cost in terms of gas, right? You need like, I don't know how many gallons of gas to do some certain number of kilometers or miles. And it's always the same. Like that cost in gas doesn't change. The cost of the gas itself might change. And this is exactly the way Ethereum works. And the way they work is that they basically let the market decide what the cost of gas should be in Ether, the currency of Ethereum. So, for example, pushing an element on the stack might have some costs. And it's like, I don't know, we could look at the yellow paper. I'm not going to do that, but it's let's say one gas or something like that. And so the market will basically try and let people decide how much they want to pay in Ether for that gas, that unit of gas. If people pay more or are willing to pay more, you could say that they're basically willing to pay the network more for that transaction. And so the network might want to privilege that transaction or that execution in their next block. It's kind of like the same notion as the notion of fee. So gas is on this whole dimension, and it's supposed to, as more and more people use the network, and as the network can kind of get congested, the price of gas is supposed to increase. I remember a time where, like, for a transaction on Ethereum to go through, it was like you had to pay like something like $30, and things were quite crazy. Hopefully, it doesn't happen much these days anymore. But yeah, so these kind of have unintended consequences. In terms of how often the protocol upgrades, I wanted to talk about that. We're really not like Bitcoin, where things get upgraded every centuries or third moon, or I don't. And in Ethereum, basically things get upgraded pretty often. There's quite a strong community of core developers behind the project. There's the Ethereum Foundation behind the project. And when people want to make upgrades to the project, they write what we call EIPs for, I believe, Ethereum improvement proposals. Some of these EIPs end up becoming standards. And the most famous standard, which is called ERC, Ethereum Request for Comment, in the world of Ethereum. The most famous one, and I believe the first one, was ERC20. And it became so famous that people tend to refer to ERC20 even in other cryptocurrencies when people tend to build the same kind of stuff. What is ERC20? It's the standard for tokens. So whenever you hear about tokens, crypto tokens, and maybe stable coins sometimes, maybe meme coins, or ICOs for initial coin offerings, and all of these things, often behind it, there is a smart contract that follow the ERC20 standard. You don't have to follow a standard to create your own coin, but if you follow that standard, it's easier to interoperate with other smart contracts and other applications and so on. Remember, smart contract can call other smart contracts. And so there's a lot of applications on Ethereum that are compatible with any types of tokens because they expect a token to follow that ERC20 standard. I actually have the standard in front of me somewhere. Maybe I can pull it up and I can tell you more about this ERC20 as, I think, a good example, because this is often something you tend to use in the Ethereum ecosystem. This is also often the first smart contract that anybody deploys to learn about the Solidity and the smart contract system. This was my first smart contract actually that I deployed. So it's a good way to learn the language. The standard ERC20 actually is pretty short. It's very, very short. I would say like 1 page or 2 pages. It's called ERC20 token standard. And Vitalik Buterin, the creator of Ethereum, is one of the author. The other author is Fabian Vogelsteller, and it was created in 2015, so quite some time ago. And it says simple summary. There's one line, a standard interface for tokens. So there's really, if you look at it, there's nothing exciting about it. It's just like a very short page and a very short specification. And it says, what does it say? It says you need a few functions. Some of them are optional functions. For example, you can have a function called name, and it returns a string, which is the name of your token, but that's optional. You can refer to a token by its address all the time, always, so you don't need a name per se. There is a symbol function that returns a string as well. This is the ticker or the symbol of your token. And then decimals, this is the number of decimals for your token. And that's also optional. But if you look at this is more interesting, the mandatory, the required functions that your smart contract needs to expose to follow the ERC20 standard, there's a total supply function that tells you exactly how many tokens are in circulation. Balance of, that takes one argument, which is an address, and returns the balance of that address. Often the state of an ERC20 contract has a hash map or a dictionary called balances, and it allows you to store a balance for any address on the network. And so this balance of function that basically allows you to query that hash map. There's also a transfer and transfer from function, and also a proof function. All of these are ways to transfer funds. Let's just look at the transfer function. It takes an address and a value, which makes sense, right? You're trying to send money to someone else. It doesn't need to take the address of the sender, because that's just the person that signs the transaction. We already know who the sender is, or the person calling that function, because the sender can actually be another smart contract. And maybe I'll give that example after. The transfer function returns a Boolean to tell you if the transfer was successful or not. So a very simple function. And if you look at the implementation of that function in most ERC20 contracts, it's very, very small. It's probably like 6 lines of code. And finally, there is an allowance function. Returns the amount which spender is still allowed to withdraw from owner. Okay, this is another one that's kind of a utility function to make transfer more easy than just a transfer function. So I'm not going to talk about transfer from, approve, and allowance. I'm just giving you the example of this transfer function because I think that drives the point well enough. And then you have this notion of events. Maybe I'm not going to talk too much about that, but like in any other languages, you can emit events when you do things. There's 2 of them. There's transfer and approval. The transfer event, as you can guess, is emitted when there's a successful transfer. And this event carries 3 values: the address of the sender, the address of the recipient, and the amount that was transferred. And so if you want to build an application off-chain, for example, you're like a centralized exchange like Coinbase or Kraken or whatever, you might want to use these events because they're an easy way to query what has happened in the history of a smart contract. So it's really a handy, API thing. You don't really have to think too much about it. It's just a handy way for people to use the state of Ethereum to create applications off-chain. Okay, so I gave my example of ERC20, and I also wanted to give the other example of a wallet. You can actually, since a smart contract is an account, you can also create wallets, which are smart contracts that control an account. And so you can send money to that account, but to use that account, you cannot use the private key of that account because, as I said before, nobody knows the private key of associated with the contract, with the address of a smart contract. And so you have to use the smart contract to use the funds locked in that account. So people create all sorts of wallets, but the famous or the well-known ones are multi-sig wallets where you need multiple signatures and multiple owners to come together to sign to unlock or to spend some funds in the contract. Okay, so this is the only example I'll give, but I would encourage you to use that remix tool that I've mentioned and try and deploy your own ERC20 smart contract. You'll see that you can basically copy paste it from somewhere. Open Zeppelin is known to have good libraries and good templates, and you can copy paste that. You can copy paste that into Remix, and then you can deploy that in your fake blockchain that will run in the browser. And it's very easy. It will take you a few hours to really understand these things. If you're really fast, it'll take you 30 minutes, and it's a really great way to get into the mental model of how Ethereum works. I think I want to stop here. There's a lot more to say about Ethereum. Ethereum doesn't really work like Bitcoin nowadays. It moved to a proof of stake thing, so I'll do an episode on that. But if you think of Ethereum these days, it's much faster than Bitcoin, and for reasons that we'll see. There's a whole ecosystem of applications that use these tokens that we call DeFi, for decentralized finance, where all of these smart contracts are basically imitating the traditional finance system of the stock market and derivatives and all these kind of crazy things. And you can lend money, you can borrow money, you can do all sorts of crazy things on Ethereum today. And things that are maybe half of the episodes on Ethereum that I'll be recording will be on layer 2s on Ethereum. And I've talked about layer 2s in the previous episode on Bitcoin, but layer 2s on Ethereum are like this huge dimension. And if L1s and layer 1s and cryptocurrencies are complicated, you can think the same of L2s. It's its own like a can of worm to open, and it's going to be very interesting. But so anyway, I think I've already spent enough time introducing Ethereum. If you have a preference in terms of what I should talk about in the next episodes, please let me know. But in the meantime, see you in the next episode. I'm David Wong, decrypting the future one block at a time.